programs and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Hello and welcome back to Dave and Mackie's Shiny Side Out. That's us. I've adjusted my volume, my input volume, so you let me know.
Way loud now. Yep.
Okay. How about this? Is this better?
That's better.
Okay. Now here we go. Okay. We are talking to you today about, again, the human animal hybrids, which is a fascinating topic. Before we do that, though, please donate if you can. This is listener funded radio, so any little bit helps. If you can donate, any currency is good, including crypto. If you can't donate, that's okay too. Please go ahead and tell people about the station. You know, that helps a lot because, you know, one of those people might be able to donate. So it's all good. It is all good.
It's also show 692.
290 and 600. Thank you, sir. Absolutely. We're 8 shows away from 700, and we all know what that means. Yes, that's right.
A whole year's worth of what's the show title?
Awareness Cascade.
That's right.
It's going to be the Awareness Cascade and the hypothesis, really, which I think these days it's more of a theory than a hypothesis, but we won't get into that. Let's not take away anything from this one. Now, in the text, I can't remember which question we got up to, 14, 15, 16, do you recall? Or was it earlier than that?
We are at number 13. But, Mackie, I wanted to show everyone something, if I can, because...
Please.
Part of... Did you see what I posted this week? I don't know if you did.
You posted great many things, my friend.
I do that. Hang on a minute. I'm going to get
Did you see the cloud in the sky today?
Yeah,
you know that
there
cloud.
Was a thing. Yeah. There was a thing with the, and the, whatchamacallit, just happening.
Right.
Yeah.
Everything is clear.
So, you know what I look like, Mackie? You know what I look like.
Oh, that. Yes, I did see that. Yes,
yeah.
I did see that.
So I'm going to put this up on the screen. Okay. So here is what I did. I took a photo of myself using Snapchat, and I just chose a couple of things, and this is what came up. And one of my friends was like, "Oh, I haven't seen you for ages. Do you look like that?" I go, "No, I don't actually." I said it's only a thing, and possibly when I posted it, I said, if I had access to CRISPR, I could look like this, is what I said. Now, not a single person, Mackie, not a single person asked, what is CRISPR? No one.
Really? Maybe they know.
No, they don't. Not even. Right, so I thought that was very interesting. Not at all.
Oh.
And I thought that was so funny for them to not understand what I was talking about, that they decided, look, if I ask, maybe I'll look stupid. Who knows what this CRISPR thing is? So,
wow,
what a segue, Mackie. What is CRISPR?
Well, what is CRISPR? That's actually, are we up to limitations or lab working on?
Are there limitations
number
to
12.
what CRISPR can do?
Perfect. So the answer, so before I answer that question, so CRISPR is essentially a gene editing tool. That's what it is. Okay, that's what CRISPR is. Now, yes, there are limitations to gene editing, but new technologies are trying to expand the power of CRISPR. Now, Dr. Chi here says in the long answer, one major limitation is we've been using it for only 10 years, which is really, in the scheme of things, not a very long time if you think about it, but the implications are staggering as to what it can do, really. back to the text. Often, time is the best test of all technologies. Only by collecting data over enough time in all scenarios will we be able to understand everything about these technologies, like how safe they are over the long term. That's a good one, Dave. Safe. Don't worry. In testing in human subjects with patients, even though we didn't see off-target effects or immune responses, there are still question marks. We still need to constantly improve our understanding, as well as CRISPR's accuracy and precision in different human tissues and different patients when treating a problem. Also, right now, CRISPR is mostly used as a molecular scissor to cut DNA. Okay, but sometimes the problem gene's affected function isn't caused by a DNA mutation. Sometimes it's a gene turning on or off abnormally that causes the problem. So editing won't do anything, right? So in that case, CRISPR shouldn't be used as a molecular scissors to cut DNA, but rather as a switch to restore the gene to work properly, right? So it's not a tool that you have to use in a certain way, but you can use it in different ways. Is really the point here. Epigenetic editing tools can well address such challenges. CRISPR is like a powerful hammer, but the question is this: where is the nail? What is the most suitable nail to work on? For example, as of today, we still don't know for sure which gene causes Alzheimer's disease in many patients. In fact, we don't even know if it is a gene that causes it in the first place, to be clear. To use CRISPR, we need to know which gene to target and which cell is the destination. We also need to know when to perform the treatment. Sometimes treatment can only be done in an early stage of a person's life. Another big issue is the high costs associated with the current CRISPR medicine. How to reduce cost is a major question. I'm glad that's Dr. Chi. I'm glad that there are active conversations between academia and industrial partners to have multiple experts in the same room to come up with the best solution. Yeah, it's always good to involve big money in these things that have profound impacts on the human condition. Always good to have the money people in the room, Dave.
Despite the prior acknowledgement that this is extremely cheap.
Yes.
So,
but see,
if you can have high-paid doctors.
But as soon as the corporate types come in, right, and then somebody wants to get paid, all of a sudden, no, not enough, need more, what? What do you need? Money, fine.
And money fine, and we need 30 layers of management above the single person doing all the work. I love that. Large corporate, I love you. So this leads us to question 14. What do you think CRISPR is capable of doing in the future? The short answer: it could help improve the quality of life as we age, engineer useful organisms, and even serve as a universal vaccine against viruses. And now Chi's long answer. I'm excited by CRISPR possibly helping anti-aging, but less in the sense of making people live longer. No one can escape aging. Of course, that's not true. And it's a huge burden to our healthcare system and decreases the quality of life. My hope, says Chi, is that in the future, CRISPR isn't just being used to save lives, but also improve the quality of life when people age. I also hope CRISPR can become a way of engineering a lot of useful life forms. For example, there are microbes that can capture solar energy and convert it into electricity. And maybe those could be used to produce sustainable energy. Additionally, we could engineer food. Hey, Bill Gates, just looking at you, looking at your direction. That's more nutritious, prevents obesity, and so on. Another application could be vaccines. Even now, infectious diseases like COVID-19 have dramatically changed everyone's lives, which is unbelievable. So another dream is to develop cheap and safe genetic vaccines to fight all viruses, since that's their original role in bacteria. And maybe in the future, we could receive a small dose of CRISPR that would completely kill any new virus. It's not easy, but given that this genetic system was designed as an antiviral system, there's a chance this could work.
So again, CRISPR is not something that we build, but it's part of a bacterium's biological makeup. It's like the immune system for bacterium. Okay, that's really what CRISPR actually is. And we just discovered it, and now we are using it. And you have used it now, as they said, for a little while. Just imagine what could be done. I find that interesting here. I also hope CRISPR can become a way to engineer a lot of useful life forms, right? And this is really why we talk so much about CRISPR here, because again, human-animal hybrids, right? I mean, could there be an easier way to get there other than CRISPR? In my opinion, probably not. Probably not. And we've already done it. Chimpanzee. Oh, don't worry, we'll talk about that, my friend. Mm-hmm. But see, ultimately, we can overcome any breeding problems, right? Let me just spend 2 seconds on this before I go to the last question here. The problem, of course, is when you interbreed species, you might not be successful. It might not work, mm-hmm. right? Because the semen of one can't fertilize the eggs of another. That's possible. Or if you can do it, you create offspring that is completely incapable of reproducing in the future, like a mule, for example, right? Mm-hmm. Horse and donkey. So these are all things that could happen, right? Whereas if you go straight into the genetic material, so you're no longer breeding. You're no longer worried about inseminating one species with another species. That's actually no longer happening. What you're doing is you're taking genetic information from one species, whatever it might be, right? You've identified here it goes like a strand of DNA, and put it into another species. So completely sidestepping any breeding considerations. In fact, you've now created a new species without ever having to interbreed anyone, right? And as our understanding of genetics evolves and our use of CRISPR and other tools increases and it becomes more proficient, we will be able to create a whole set of new species, hitherto completely thought impossible. I want to submit this, though, to the ladies and gentlemen of the jury. Think about all the creatures of mythology that they tell us about, mm-hmm. right? The Minotaur and the Centaur and Pegasus, Unicorn, etc., etc. There's so many, the mind boggles.
Anubis? Is that the one, the bird-headed one?
The god, yeah. God Anubis, correct. Now, what if this technology, because here it is, right? And we don't know how far we can get, with it in the future. Certainly, we can't even imagine today, I think, what we can do with it. But what if, since this is not something that we invented, we found it in a bacterium, okay? What if someone else before us found that or something similar in a bacterium or somewhere else, mm-hmm. and used it in the same way or even more proficiently than we're using it today? Tens of thousands, hundreds of thousands, millions of years ago, right? Can we dismiss that? No, we cannot dismiss it because we don't know enough to dismiss it. So all these stories of these mythological creatures, well, some surely you'd think are made up and, are just some, form some part of the archetypes in our collective unconscious. Others, in my opinion, are quite real. I think they did exist at some point, and then they may still exist in some hidden areas of the world, potentially, okay? Including any kind of alteration you can imagine that would have been made to the human experience, from giants to tiny little creatures, different colors, different features, mer people, and why not? I mean, why is it such a huge step to imagine a race of Homo sapiens, or a species of Homo sapiens, that could live and breathe underwater? It's not really that amazing. I'll tell you why it isn't amazing. The first 9 months of our life, do you know what we breathe? Not air. Our lungs are filled with amniotic fluid, which carries oxygen, which makes us breathe the oxygen from the liquid in our lungs. They have developed for deep sea divers systems of fluid that is pumped into your lungs, that allows you to breathe at extreme depths. Because the one thing that you don't want in extreme depth when deep sea diving is to have any hollows in your body, because they would collapse, from the pressure. Whereas if you can equalize the pressure more or less, then you have a better chance of survival. So we have created human beings, or a technique at least, that would allow you to breathe this liquid that is pumped into your lungs. That's a thing that actually happened. Right? Now, is it really that hard to imagine a species of Homo sapiens that has the ability to extract oxygen from water? I mean, there's a plethora of other species that can do it. Why not engineer gills or something like that for humans? Of course we could. Of course we could. So I just want to open people's eyes to the possibilities here, right? So that brings us to question number 5 quite nicely. A nice segue, even if I say so myself. How far are we from achieving those idealistic future goals? Short answer. We are close to some goals, but maybe far from some other idealistic goals. So we don't really know. But the longer answer of Dr. Cheese is this. When it comes to CRISPR and achieving those big dreams we have for it, the CRISPR dreams, we're at different stages. For some goals, it might feel like we're just starting out, but for others, we're getting pretty close. For example, that's Dr. Chi, is really excited about how we're starting to use CRISPR in real-life treatments for diseases such as sickle cell anemia. This is a big step forward. I'm also very excited about CRISPR epigenetic editing, a way to turn genes on or off without changing DNA sequences, which is getting ready for its big moment in clinical trials. Last year. This article is from last year, okay? Same time last year. The reason we've come this far is thanks to a lot of people who believe in the power of safely editing our genes to make us healthier and are working hard every day to make that a reality. It's their passion and the demand for these solutions that keep pushing us forward. I'm optimistic that many of the things we're dreaming about with CRISPR could become real sooner rather than later. This was taken from Stanford, the Stanford magazine. Like I said, the gentleman who gave the longer answers here is Dr. Stanley Chi from Stanford University. He's a bioengineer there. So June 10th, so it's exactly a year almost that this article was published, June 10th, 2024. I am both in awe, Dave, and slightly terrified as to what the future might hold in this space.
I'm not going to call you a wuss for being scared of the unknown, but I think it's a very generous description of how you should feel, because we know of the people in the world who, with this power, could do whatever they wanted. And I think that's where the real fear should be, is not the tech itself, but who's going to be holding it. So, what, Meki, are the benefits of CRISPR? And I think if we take these one by one, it might sound more interesting to the viewership. So, CRISPR gene editing technology has led to numerous significant advancements across various fields. Some of the most notable achievements include, number 1, precision gene editing. CRISPR has revolutionized the field of genetic engineering by providing a precise and efficient method for modifying specific genes. This level of precision allows scientists to edit DNA with unprecedented accuracy. There's that word again.
Thank you. Oh, absolutely. And this article was actually published in April 15, 2024. The treatment of genetic diseases, this is the second point here. CRISPR holds immense potential for treating genetic disorders. Researchers have made strides in using CRISPR to correct or mitigate the effects of diseases such as sickle cell anemia, cystic fibrosis, and muscular dystrophy by editing the underlying genetic mutations.
Number 3, cancer therapies. CRISPR is being explored as a tool for developing cancer therapies. scientists are investigating ways to use CRISPR to target and eliminate cancer cells by modifying specific genes involved in cancer progression.
The fourth point is functional genomics. CRISPR has significantly advanced functional genomics research. It enables researchers to systematically and efficiently study the function of individual genes, helping to uncover their roles in various biological processes.
Agricultural advancements, which is point 5, CRISPR has been applied to agriculture, leading to the development of genetically modified crops with improved traits such as resistance to pests, diseases, and environmental stress, like frost. This has the potential to enhance food security and sustainability.
6. The creation of disease-resistant animals. CRISPR has been used to create genetically modified animals with enhanced resistance to diseases. Livestock engineered with CRISPR may require fewer antibiotics and could be more resilient in the face of infectious diseases.
Wow. Stem cell research and regenerative medicine. This is number 7. CRISPR has facilitated advancements in stem cell research, allowing for precise modifications in these cells. This has implications for regenerative medicine, where modified stem cells could be used to repair or replace damaged tissue.
Point number 8, and this is very pertinent to our recent history. Infectious disease research. CRISPR has been instrumental in studying infectious diseases. Researchers use CRISPR to modify genes and pathogens, gaining insights into their virulence and developing potential strategies for combating infectious diseases.
Number 9, development of gene therapies. CRISPR has opened new avenues for the development of gene therapies. Scientists are exploring its use in correcting genetic defects and introducing therapeutic genes to treat a variety of medical conditions.
And finally, evolutionary studies. CRISPR has enabled researchers to study the functional consequences of genetic changes over generations. This has implications for understanding evolutionary processes and the impact of genetic modifications on species. Now, these are the positive, I guess, largely perceived to be positive, effects of CRISPR. Of course, there are also, there are also obviously negative aspects to CRISPR and the ability to gene edit. Despite all the good headlines, occasionally point out there are drawbacks to gene editing as well, and some include, Dave.
Number 1, ethical concerns. One of the most significant cons revolves around the ethical implications of altering the human germline. Editing genes in embryos may introduce heritable, that'll do, yes, changes, raising concerns about designer babies and the potential for unintended consequences.
Which, of course, is the second point, unintended consequences. And to me, unintended consequences is probably the greatest pitfall in any endeavor that we undertake. Right?
May cause gigantism.
Oh, so delicious. But it is certainly the lack of foresight, the lack of understanding, and our inability to do proper risk mitigation as well as a comprehensive pre-planning before we do anything at all as human beings, right? It's the unintended consequences that always get us. In the text here, of course, despite its precision, CRISPR is not foolproof. What a shock. Off-target effects can occur, leading to unintended genetic changes that may have unpredictable consequences. Ensuring the safety and accuracy of CRISPR interventions remains a challenge. You see, we are going into something, and we always have done this as human beings. We are going into something without fully understanding what will actually happen. When we first decided to detonate an atomic bomb, some scientists thought that we set the atmosphere on fire, right? What's the chance? Oh, it's a very small chance. How small? 99.99999 against, like tiny.
Yeah.
That's no good. Well, what would be acceptable?
Zero.
No, That's not zero. That's right. No chance would be good. To set the atmosphere on fire, no chance. Yeah, we're not dealing with that kind of. No, sorry, can't help you. Yeah, but that's a problem, of course, right?
It is. Number 3, unknown long-term effects. The long-term effects of CRISPR modifications are not fully understood. This lack of knowledge raises concerns about potential health risks and you said that, unintended consequences that may manifest over time or be passed down to future generations. You said that one, didn't you?
That's right. No.
Oh, good.
No.
Phew.
You did the right one. But see, just before we go on here with the negative impact of number 4, let's just cast our mind back to the past. And so, in my opinion, we were, maybe not us, but someone certainly was a master of genetic engineering. That's my firm belief.
Mm-hmm.
Because you look at us, there's no way we just came about like this. It's just not very likely. I mean, you can start with the chromosomal count and you ask yourself, well, how did that happen? Well, there's no good answer for that. Okay, there still isn't. But
so
certainly,
going from 48 pairs to 46 pairs was
correct.
An extraordinary step that we had seen in any other creature on the planet.
Yeah, and we have. There's none of the great apes are like that. So
and it fits the Anunnaki story perfectly, and then also the biblical story about us being given a lifespan of 120 years max.
Correct. Yeah, and see, they talk about chromosomal fusing and all kinds of things. All it means is they don't know. They don't.
That's right.
No one knows. Okay, fair enough. But again, even looking at human, the Homo sapiens, human beings, etc., and the way we are, our complete lack of adaptability when it comes to the way we are actually physically, right? We've got back pain, our heads are too heavy, our children have the heads of our children are too large to give birth easily. There's no creature in the world, not one, that has a problem giving birth. Not one.
Right. Mm-hmm.
We are the only species that has trouble in that space where the incidence of both the child's death as well as the mother's death are not uncommon, right? In medical or pre-industrial cultures, right? And I guess that's also the reason why our population didn't explode the way it has exploded now, because the childbirth process is extremely stressful on the body. In fact, unreasonably so. The human head is too large to pass easily through the birth canal, right? Which gives, again, in my mind, rise to certain theories around birth mothers, as that I mentioned in the Anunnaki text.
Oh, I know.
As well as the fact that, I know, right? We have recently developed, I don't know about perfected, but we've developed an artificial womb that is promising to allow a fetus to gestate outside the human body completely, from beginning to end. Completely doing away with the need for a woman, or a man, as the case may be in the future, to carry a fetus. Completely done away with that. Okay? Now, this is quite terrifying in some ways, but if we were, this is the text of the Anunnaki, the epic of the Enuma Elish. I think that's what I'll look it up for you guys, but I think it's the Enuma Elish. It's a part of the hypothesis, so we'll get. In there, they're talking about 9 birth mothers that they crack open, right? Or 7 men, 7 women. I can't remember the exact number. This is birth mothers, right? And womb mothers.
That's right.
And they open them up and see this is where the human being are gestating. So they're not gestating inside a human body. They're gestating inside these womb mothers. There's another story, interestingly enough. After the flood, people were grown on trees. Okay, now look, if you have an artificial womb, right, and of course you could have it in a structure that resembles a tree, like where the children are hanging like fruits on these in these artificial wombs. I mean, if you wanted to do that, or something that could resemble like a tree structure, right? Coincidentally, potentially. But my point here is this: I think that we have been interfered with on a genetic level in the past. I know a lot of people got crazy talk, blah, blah, go home, you're just insane. Well, this is the shiny side out, so I can say whatever I like. And there is some evidence for it, and there's certainly some textual evidence for that as well. Okay, and we were actually engineered as a worker class to take the load of the Igigi, right? To start working for the Anunnaki, and the Igigi became our overseers. Point is, they were masters of genetic engineering, I'm sure, and they may very well have been a Homo sapien species, because again, we are, according to the story, we are made up of them and of Earth-born material. Okay? And this is really important to understand, that there seems to be some kind of hybridization that went, right, between them and us. And I will further submit that this hybridization would have been completely impossible unless the Anunnaki themselves came from here. All right? Just another species, much more highly developed, probably a spacefaring species, but nonetheless of Earth. Right? Because no matter how good your genetic engineering is, in my opinion, if two species come from two completely different planets, where DNA might not even be a thing, right? I find it highly unlikely that they could be interbreeding even in a hybridized situation. But that's just me talking about, right? Anyway, point number 4, socioeconomic disparities. This is the cons of gene editing. This is a really important one, because we're already there anyway, without gene editing. The accessibility and affordability of CRISPR technology may create disparities in its use. This could lead to unequal access to technology, such as, gene therapies, exacerbating existing social and economic inequalities. So, already we are there. We are living in a world of significant inequality, where life expectancy is very, very low in poor countries. Child mortality is high, hunger is high, no future, etc., etc. Whereas other countries, we are battling not starvation, we are battling the other spectrum, the other end of the spectrum diseases like morbid obesity, like I call it. Okay, it's not called morbidity, morbid obesity. So we're not starving, but funnily enough, and this is true, people that are starving are dying from malnutrition. People in developed countries that are morbidly obese are also dying from malnutrition. Mm-hmm. Except doctors couldn't diagnose it for the longest time because they had never seen it. And clearly, this is a hugely overweight person. How could they possibly dying from malnutrition? It's because they don't get the right nutrition into their body. That's why.
That's right.
Right? It is actually complete insanity if you think about it, but it's true nonetheless. So you have this dichotomy of the same kind of outcome. Ultimately, you're dying of malnutrition. Right? But this inequality that exists in our society will only be exacerbated by something like CRISPR. And it will actually make it a genetic imprint. Already, and Dave and I talked about this. This is important at this point. Sorry, Dave. We talked about the impact of poverty on your telomeres. Okay? And your life expectancy. So studies have found that people who live a fairly stress-free life, right, like an easy life, let's call it, okay, pass much longer telomere chains onto their children than people that grow up with a lot of stress or live with a lot of stress, like, poverty, starvation, whatever the case may be. They pass a lot shorter telomere chains to their children. Why does it matter? It matters because longer telomere chains, theoretically and practically, in my opinion, mean that you probably will age more slowly. You will probably be less susceptible to certain diseases. So you probably have a better quality of life. So the difference between rich and poor, right, which is expressed in, I guess, the level of stress that you experience as an organism, leads to your life expectancy as a child already be lower. Even if you, as a child, make your way out of poverty and live now a relatively stress-free life, you were already born with shorter telomere chains. There's the study that I think it'll come up in the hypothesis. But that's and this CRISPR technology will only exacerbate.
That's true, totally true. Just to make a finer point to it, the longer your telomeres are, and the longer your longevity or the slower your life is, because that your aging process doesn't kick in so soon, means a longer reproductive cycle, and you have a shorter telomere or more disposable telomere chains, and therefore a much shorter reproductive cycle. It's much more rapid because you have to be able to get that done before it's too late. Let's say, put it that way. Meki, there's another impact here, which is environmental impact. Just thinking about genetic modifications in agriculture may have unforeseen consequences on ecosystems and biodiversity. You might make something that was so immune to everything that it just covers the planet really quickly, and with no
Yes.
think about it. So with no natural predators, it could just overwhelm all of the other plants. So the release of genetically modified organisms into the environment raises questions about the potential ecological impact.
And we already know what we. I mean, you're right.
We're good at
100%.
this.
That's a very valid.
We're so
point.
good at this.
Well, yeah. Look, if you look at a very simple thing, if you look at in Australia, we had a problem with the cane beetle, right? And the cane beetle ate the leaves of the cane and the fruit, and so it damaged the canes, let's call it, right? The sugar cane. So that's what happened. What do we do? Well, what do we do? Well, I know. We'll introduce cane toads. Now, the problem with the cane toad is this. Not only did it not eat the beetles, but it would never have eaten the beetles because the beetles live, I think, 30 or 40 centimeters
on the top
above its hunting ground. Yeah.
And the cane toads can't climb.
That's right. So never the twain shall meet. That's right. So the cane beetle kept spreading, and the cane toad kept spreading. You know, the cane toad, being an introduced species, is actually toxic for any Australian native predation.
Yeah.
Any predators that would eat it can't. It'll kill them most likely, or at the very least make them very, very sick.
Or
so cane toads are now.
If you have pets, if you have dogs, and you live in an area where they've now overrun the natural species for that area, the dog will just, having licked the back of a cane toad, will just stand and stare and bark at the fence, and for no reason whatsoever. It's got its own little exactly DMT thing going on, Meki. You can see the aliens.
No, but and that's an organism that we haven't modified in any way. This is just a natural look. But in Australia, we had a lot of problem with introduced species. I know in America, the fire ant is an issue, and the African killer bee is an issue. But
fire ants now in Britain.
It's here, yeah.
Yeah.
Correct. And then obviously we introduced rabbits. That's a massive problem for Australia. We introduced foxes, another huge problem for Australia. So we're really good at introducing species into environments they shouldn't be in. And so yes, this is a big one. A lesser drawback here, and I say lesser because it has nothing to do with anything really, are regulatory challenges. This is really just us on how we want to use something in an ethical fashion. The rapid pace of CRISPR advancements has outpaced regulatory frameworks. Establishing guidelines and ethical standards for the responsible use of CRISPR technology is crucial to prevent misuse and unintended consequences. Now, just on that, Dave and I spent 6 or 7 weeks talking about human medical experiments.
That's right.
And how long it had taken to even come up with the standard.
That's right.
Because it didn't exist really prior to World War II. Not really. And even after World War II, to some extent, we're still trying to work it out. I mean, now we've got to, I guess more or less, we do have a framework around medical experimentation and informed consent and things like that.
That's right.
Correct. And in fact, the Nuremberg, the German scientists in the Nuremberg trial said, well, you've done the same thing, America. Look over here.
That's right.
Look what you did.
They're like,
right?
What? Where?
And
what?
Yeah.
I said, no, pantomime.
We never saw that.
It's a panto. It's behind you. Where?
That's right. Exactly.
No, and it's like, it's like a magician. It's like, I'm going to distract you, and it's over there. It's crazy, Meki, that what we had discovered was that all the countries were doing whatever they could as soon as they could, and without any moralistic view about how even using the data from the past before the framework was put in place, how does that affect your use of that data, right? So all of that the Hippocratic Oath was formed and developed as a result of that code, that framework. You think about the most deaths that occur, I heard a stat about this and I don't know the percentage, are caused by doctors. The most deaths are caused by doctors worldwide. Believe it or not.
Yeah, iatrogenic death. That's correct.
Thank you.
Medical malpractice. Yep.
So, look, it's a concern. Are we going to get any better? I don't think that's going to happen anytime soon. Or the fewest, let's project this out past World War III. The fewer of us that are left are more than likely going to be kinder to each other. Let's put it that way. After the King of the Thieves.
Thanks for taking it there. Mad Max.
You know, it's human animal hybrids, updated version 2. Will we get better at it? I don't think so. It's the human race. We're very slow. So was that the dual use concerns you read out?
No, that's yours.
Oh, fantastic. The last point in this crazy long list is number 7, dual use concerns. CRISPR technology can be used for benevolent purposes, but its dual use nature raises concerns about its potential weaponization. The ability to engineer pathogens or create genetically modified organisms for malicious purposes poses a security risk. No, that's perfectly cromulent.
The vessel with the pestle holds the brew. That is true.
That's right. That's exactly right. So Meki, just an example about this. We do have labs right now where people are creating viruses and modifying them. I think we all understand what that means these days. And most of us never knew we would learn that in our entire lives. But there it is. It's out there. Where there are people who are currently working on just the bacteria that can grow on the heads of wheat, for instance, and what that might mean. And now you think about if you weren't in a level 3 or level 4 lab working on this and any of it happened to get out, it could decimate your industry entirely. Could make it so we don't get any more wheat ever again because we can never grow it.
Look, we faced similar things like bananas, for example, right? The Cavendish variety that we all eat was almost wiped out by a disease. Now,
I've got a great example about that.
Yeah, go on.
Well, you know the little lollies, the little fake banana lollies, and the banana flavor that is in those lollies. Sorry, candy if you're in America. The little banana. You don't, when you eat it, you go, oh, that's a banana flavor, but we don't have a banana currently that's in any marketplace on the planet that tastes like it anymore. Did you know that?
No, I did not know that.
The banana flavor that it came from is now extinct in real life. We don't have that banana any longer. And that's why there's such a disparity between the flavors. But initially when it was produced, we used to have that brand or, that species of banana. Extraordinary. It's gone.
That's a really good point, actually. Now, I just want to throw it out to the chat room as well. Omega Logos has made some excellent comments there. I just want to that are pertinent to what we've just shared. Now, Omega Logos said, super soldiers here we come. 100%. 100,000% super soldiers here we come. And also, BioWar would of course apply the dual use. And he also mentioned a few native snakes in Australia that have adapted to the cane toad. But I guess the scariest point is, decimation, you're right. It comes back from the Roman times when Julius Caesar actually started the program that was called decimation. and every 10th person, be it a legionnaire or an enemy, would be killed or maimed, as it were, in order to teach the rest of the enemy or the troops a lesson. That's where we get decimate from. So yes, it could destroy mankind entirely, not just 10%. You're correct. But yeah, the term decimation, the origin of it is goes right back to good old Gaius Julius Caesar. You know, one of the leading lights of genocide and exploitation and slavery in the human experience. So thank you again. I want to just highlight the fact that the chat room is awesome. Please do go into it if you can and interact with us. We will keep an eye on it and comment whenever we can as well. So please do that. And thank you so much, everybody in the chat room that gives us the comments and the extra information. It's really appreciated. Okay, we still have some time. I think we can get through it, my friend. So let's get to it. There's nothing to it but to do it. Human-animal hybrids. Excuse me. The terms human-animal hybrid and animal-human hybrid refer to an entity that incorporates elements from both human and non-human animals. These hybrids existing throughout social cultures for a long time, particularly in terms of mythology, while also being thought to be theoretically possible via scientific experimentation. Whoa! Dave?
Yes. A description. For thousands of years, these hybrids have been one of the most common themes in storytelling about animals throughout the world. The lack of a strong divide between humanity and animal nature in multiple traditional and ancient cultures has provided the underlying historical context for the popularity of the tales where humans and animals have mingling relationships, such as in which one turns into the other or in which some mixed beings goes through a journey. Becky.
Interspecies friendships within the animal kingdom, as well as between humans and their pets, additionally provides an underlying root for the popularity of such beings. In various mythologies throughout history, many particularly famous hybrids have existed, including as part of Egyptian and Indian spirituality. The entities have also been characters in fictional media more recently in history, such as in H.G. Wells' work The Island of Dr. Moreau, adapted into the popular 1932 film Island of Lost Souls, and there have been other adaptations since then, I just want to say here. In legendary terms, hybrids have played varying roles from that of trickster and or villain to serving as divine heroes in different contexts, depending on the given culture. For example, Pan is a deity in Greek mythology that rules over and symbolizes the untamed wild, being worshipped by hunters, fishermen, and shepherds in particular. The mischievous yet cheerful character is a satyr, who has the hindquarters, legs, and horns of a goat, while otherwise being essentially human in appearance. With stories of his encounters with different gods, humans, and others being retold for centuries on after the days of early Greece by groups such as the Delphian Society. Specifically, the human-animal hybrid has appeared in acclaimed works of art by figures such as Francis Bacon. Additional famous mythological hybrids include the Egyptian god of death, named Anubis, which we mentioned earlier, and the fox-like Japanese being that are called Kitsune. It's like a nine-tailed fox. When looked at scientifically, outside of a fictional and or mythical context, the real-life creation of human-animal hybrids has served as a subject of legal, moral, and technological debate in the context of recent advances in genetic engineering. Defined by the magazine H+, as genetic alterations that are blending of animal and human forms, such hybrids may be referred to by other names, occasionally such as parahumans. They may additionally be called humanized animals. Technically speaking, they are also related to cybrids, cytoplasmic hybrids, with cybrid cells featuring foreign human nuclei inside of them being a topic of interest, Dave.
Possibly a real-world human-animal hybrid may be an entity formed from either a human egg fertilized by a non-human sperm or a non-human egg fertilized by a human sperm. while at first being a concept in the likes of legends and thought experiments, the first stable human-animal chimeras, not hybrids but related, to actually exist were first created by Shanghai Second Medical University scientists themselves in 2003, the result of having fused human cells with rabbit eggs. As well, a US patent has notably been granted for a mouse chimera with a human immune system. In terms of scientific ethics, restrictions on the creation of human-animal hybrids have proved a controversial matter in multiple countries. While the state of Arizona banned the practice altogether in 2010, a proposal on the subject that sparked some interest in the United States Senate from 2011 to 2012 ended up going nowhere. Although the two concepts are not strictly related, discussions of experimentation into blended human and animal creatures has paralleled the discussions around embryonic stem cell research, the stem cell controversy, if you will, the creation of genetically modified organisms for a multitude of purposes has taken place in the modern world for decades. Examples being specifically designed foodstuffs made to have features such as higher crop yields through better disease resistance. Despite the legal and moral controversy over the possible real-life making of such beings, the then President George W. Bush, even speaking on this subject in his 2006 State of the Union, the concept of humanoid creatures with hybrid characteristics from animals played in a dramatic and sensationalized fashion has continued to be a popular element of fiction media in the digital age.
And I think at this point, we really need to consider that this will become a reality rather than just some kind of thought experiment. Right? Technologies such as CRISPR and other things that will come after it will see us having to deal with these questions. I mean, probably won't be able to get too much further in the text, but let's just think about this for a second here, right? Let's say we do start hybridizing humans and other species. Maybe even the great apes. Maybe even dolphins. And why not, right? Whales, who knows? And we're looking for very specific characteristics when we create these species. Now, if they are human-animal hybrids, okay, I think there will probably be a sliding scale. But what I mean by that is, how human is this new creature, right? Is this very human? So if it's very human, then does it have human rights? Is this now a person under law, right? And or not? I mean, the thing is this: we are already creating babies in labs, like in vitro fertilization, etc. Right? I mean, we are doing this today, right? So they're full human beings once they're born. So now we're doing that with hybridized embryos. But what percentage do we say that this creature, this child, this baby, whatever, is a human being, and then what percentage does it cease to be a human being? Right? We will have to ask the same question when it comes to cybernetic organisms. The more we replace our natural biological parts with mechanical parts or cyber, electronic parts, as it were, then we also have to ask the question: at what percentage do we stop being human? And this is the same question, right? And I don't know what the answer is. Like I'm not offering a solution here, but then are you allowed to even bring these creatures into existence without their consent? If we consider them human, right? They would fall under human experimentation, and in order to create them, even we would need their prior consent. If you follow it through logically, of course that's not possible, right? You can't do that. And then let's say they do get human rights, for argument's sake. If they're 95% or higher human, for argument's sake, right? But they're further away from us than the great apes are. Right, at 95%, for example, or 90%, or whatever the number is. And they have, let's say they have the intelligence. Well, if they have the intelligence, right, then how will they feel about their existence? How will they feel about being used by human beings or having been created by human beings as tools? I mean, this will open a Pandora's box of such immense size that we can't even begin to understand what would come out of it, right?
Think about the complexity
we just
of their abilities if they were better than us.
Yeah,
maybe
exactly.
They were more intelligent.
Are they stronger?
Maybe they could just tear our limbs off, right? Or maybe
but you're right.
For whatever reason, then how would we consider it? But there's the music.
And yeah, that's but everybody, we are approaching the singularity from every angle. Are we going to be replaced as a human species?
There's the music. Meki, I'm going to say, what do we ask of our listeners every week?
Be safe.
Be safe, everyone.